I'm going to be walking through the steps of math induction. This is for number 3 on the homework. So the first step, you write the equation down. It's best if you write the equation down so you can see how it's going to look, so you can split it into columns. So on this we have 2i minus 1. So the first step you want to do is this left side of the equation, you want to set it into a series. This side of the equation before the equal sign. So to set it equal to series, you plug in 3 values for I. So 1, 2, and 3. So, and set it equal to series, so addition. So for first value of I, so you plug in 1. 1 times 2 is 2, minus 1, 1. Then you plug in 2. 2 times 2 is 4, minus 1 is 3. And then you plug in the third value. 3 times 2 is 6, minus 1, 5. Plus, dot, dot, dot. And then what you do is you want to put the nth value. So you know how in arithmetic sequences or sequences in general, the final value is always n. So you know how you plug in 1 for I, you want to plug in n because that's the final value. So when you plug in n for this equation, 2i minus 1, you plug in n, you get 2n minus 1. So you write over here 2n minus 1, and then you set it equal to n squared. This side does not change. Next step, you want to set n equal to 1 to test if both sides are correct. So you want to test the first side. So if is the first term, what is the first term? When you plug in 1 into this thing, you get 1. So the first term on the left side is 1. And when you plug in 1 for n over here, n squared, or 1 squared, is 1. So this step is correct. If this step is wrong in one of your math inductions, it is automatically incorrect. Moving on. Next step is the step where you assume n is equal to k. This step is to help you with later steps. You won't do anything super special except for switch the variables for n and k. So every single n variable in this equation becomes k. So it'd be 1 plus 3 plus 5 plus dot 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 2k minus 1 equals k squared. Then the next step is to show k plus 1 is equal to n. So k plus 1 is the term that comes directly after k. So if k was 1, k plus 1 would be 2, meaning it's coming directly after. So you want to set up a series like you did over here with k plus 1 as the variable. So 1 plus 3 plus 5 plus dot 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 2, and you see how you plug in k over here? Every instance where you plug in k, you want to put a parentheses and you want to plug in k plus 1. So in this particular situation, it'd be plus 2 times k plus 1 and then minus 1 is equal to k plus 1 squared. Next thing you want to do is to simplify both sides of the equation. So this term and this term. Sometimes it might be better to not simplify, but because these terms are pretty simple, we can simplify over here. So it'd be 1 plus 3 plus 5 plus dot dot dot. So 2 times k is 2k, 2 times 1 is 2, and this minus 1. So this would simplify to 2k plus 1. And this would simplify to k squared plus 2k plus 1. You factor it out, k plus 1 times k plus 1. Then we go back to this step. In this step, you proved that this entire sequence, 1 plus 3 plus 5 plus all the way to the term 2k minus 1 is equal to k squared. You proved this when you checked over here.
Hello, guys.
So when you proved this when you check there, you know this to be true. So what you do is you can write k squared over here as a substitution for the term that comes directly before 2k plus 1. 2k plus 1, if you remember, is the term that comes directly after 2k minus 1 that we tested over here. And because k squared is this entire term added all together, k squared plus the term 2k plus 1 should equal this other term. And if your math is correct, it should. And because these two things are equal to each other, this proof is correct.